we spoke about these different rules, and the area rule, the sine rule, and the cos rule. And I would like to know from someone in the class, what do we need in order to use the area rule? What are we looking for if we want to be able to use the area rule? And so I'm going to give you a triangle like this. And can anybody tell me what we need in order to use the area rule? So just a plain old triangle, we wouldn't be able to use the area rule. We need a bit more. So if you think you know what the key information is for the area rule, pop your hand up or put it in the chat there.
Mr. S, Lee's hand is up.
Okay. Hey, Lee, what do you think we need to, what information do we need to use the area rule?
Hey, sir. We need two angles and a thingy. I mean, we need two sides and an angle between the sides.
Yes, we need two sides and we need the included angle. Thank you, Lee. That was awesome. So I'm just going to illustrate that. Here, there would be maybe one side. There could be another side. And then we need the angle in between. And then we can use the area rule. And so the area rule often is written like a half AB times the sine of C. That's one way of writing it. There are various other ways of writing it. In this case, okay, I'm not going to go into the specifics, but basically you're going to see this formula come up in the lesson today. And what it allows us to do is find the area of any triangle if we've got two sides and an included angle. Okay, now the second rule that we need to know about is the sine rule. And the sine rule can be used in two different ways. We can use it to find the side, or we can use it to find an angle. And what we need is matching pairs of sides and angles. The most important thing I think we need to remember though is if we're finding angles, we generally write the angle on top. So we'd write the sine rule like this. And if we were looking to find a side, we normally write the side on top. And it would look a bit like that. And you're going to see me do this throughout the lesson. So that's the sine rule. In the first scenario over here, we're finding angles. We write the angle on top, or the sine of an angle. And in the second case, when we are finding sides, we start by writing the side on top. And then we follow this pattern that I'm showing you. Okay, then the last rule that we learned about in the last two lessons is the cos rule. And when we are finding sides with the cos rule, we are looking for, again, two sides and an included angle. And often it looked a bit like this. And so that would be finding sides using the cos rule. And if we were finding an angle using the cos rule, we'd start by writing it with the angle all by itself. Now, if this is your first lesson, I don't want you to stress about this. I'm just going over the things that we've done in the previous lessons. You'll see me do it slowly when I start the questions. So this would be okay. So throughout today, we are going to use combinations of these rules to solve for either sides or angles. And so these are the tools that we are going to use today. Give me a thumbs up in the chat if you're familiar with all these tools. Give me a thumbs down in the chat if you are not familiar with all these tools. Because today is like the remix day. And again, don't like hide it. If you haven't seen all these rules, then that is something I need to know about. Okay. A bit of a mixture. So all I want you to do then is, if you haven't heard of all these rules before, what you need to do is, when you notice something you're unsure of, go back to the video where I did a whole lesson on it, And then this today will kind of be like an overview for you, and then you can trace back the areas you'll still need a bit of help with. Okay. Okay. So we're going to start with a bit of a multiple choice question, and we are going to try and figure out which of the rules we think we would use. Okay, so it's if I'm looking at the chat, I'm seeing it's about half and half. Half the students have seen all the rules, about half of them haven't. That's what I'm seeing.
Yes.
Okay, let's try and answer this multiple choice question. You are going to try and find, or you need to decide which tool would be most helpful for finding the side over here called X. You're given a choice of 4 different tools you could use. Which of the 4 are you going to use? What do you think you should use? And I would love someone to put their hand up and let me know why they chose their answer. So if you're willing to share, why did you choose? There's a mixture of options. There's B's, there's A's, there's some D's. And I want to see if somebody can tell me why they chose what they chose. Okay, who is willing to just give us an idea of what's going on there?
Mr. S. Lee has an answer for us.
Okay. Lee, which option did you choose?
I would choose option A, sir.
Okay. I agree with you, Lee. It is the
rule.
sine rule. Why did you choose it? Like, what gave it away in the drawing?
It is because we were given 2 angles and a side, an included side.
Yes. So basically, you were given 2 angles, and what you have is you have a side opposite that angle, and then you're given basically this side over here is opposite this angle. So you have these pairs of sides and angles that are opposite each other. So if I was going to solve it, I would write it as x over the sine of 29 equals 32 over the sine of 77. And so then after that, you'd have to solve for the x to get it by itself. But basically, the sine rule would be the better option. The other thing that Lee said is basically you're given 2 angles and a side. And, you know, generally speaking, that will work with the sine rule. Pythagoras needs a 90-degree triangle, and SOHCAHTOA also needs a 90-degree triangle. And so there's no 90-degree triangles here. And the cosine rule would generally get used when you have 2 sides and the included angle, and you don't have 2 sides. In fact, I actually want to just, for those who someone was saying, how do I know which things to use? Maybe you guys can take a screenshot of this little thing here. Now, I find in practice doing questions is just a helpful way to understand this. But, you know, when do you use the particular things? Well, in the sine rule, if no right angle is given and 2 sides and an angle are given, or if 2 angles and a side are given. And that was the particular scenario that Lee identified there. So this, what you need to do is in your brain, be able to apply this decision-making thing as we do questions. But my experience from the classroom is that memorizing is not that helpful. You need to kind of just do questions and practice. So that's what we're going to do today. But take a screenshot if you need to. All right, so.
Mr. S?
Yeah.
Before you continue, can you please go to back to the previous page where you wrote a summary of the formulas? I think some students missed that.
Okay, there are better. Okay, this was just a rough. I wouldn't stress too much about seeing this as the Holy Grail, because this was just a quick little rough recap. And so there are easier summaries which we can talk about in future. Okay, so I'm going to give you a hint for this first one. In this particular question, because this is lesson 7 of the lessons we've been doing, we're going to start to use 2 rules in one question. So in this particular question, it says, find the area of this triangle. Now, obviously, because there is no right angle, there's no perpendicular height, we're going to have to use the area rule. But in order to use the area rule, we need something that is still missing from our drawing. So earlier on in the lesson, I said to you, to use the area rule, we often would say it would be a half, like A, B, sine C. And I want to know in the chat, what are we missing that will stop us from basically finding the area of this triangle? Okay, Isake, I see that hand. What are we missing?
An angle.
We are missing the angle. Do you have any particular angle, Isake, that you would think we should find? Or Kuchle, I think it was Kuchle. So we need an angle. And so what I'm going to say, guys, is that it doesn't really matter which one it is because we've got 3 sides. But in order to find an angle, what rule are we going to use if we're given 3 sides? So basically, if we're given 3 sides, I'll go back to that little thing maybe. Use.
Sir?
Yes.
Sir?
Yeah. Okay, I think we've had a bit of a thing there. So for the cosine rule, if you're given 3 sides, then it's a good idea to use the cosine rule. So let's do that. I want you guys to find for me, we'll call this angle C. So we'll call this angle C, the red dot. I want you to try and find angle C for me. And then I'm going to suggest you use the cosine rule. So go ahead and find what the angle C is using the cosine rule. I'll give you a little hint to start with. You type the cos of C equals. Okay, so we're going to use the cosine rule and we're going to try and find angle C. Then once we've got C, we can then work out the area. And in the previous lesson, what I said was and I really recommend you going back to watch this lesson, is a really important side is the side that's opposite this. And so I'm going to go minus 8 squared. And here we're going to have 9 squared plus 10 squared over 2 times 9 times 10. And then we need to find out what this angle C is by going shift cos of these numbers here. So in the chat, there are a few answers, but I want to see what are we getting for the angle C if we put that into our calculators. We can even have an intermediate step if we want. So cos C equals, let me get a number there. So 9 squared. Okay, so we're getting, different people are getting different answers. Let's have a look here. So I got, let me just make sure I get here, 0.65. And then if I get 0.65, I now go shift cos of 0.65, shift cos 0.65. And we should get 49.46. So C equals 49.46 degrees. So What that means is we have found the size of this angle over here. It's 49.46 degrees. Now what I want is I want the rest of us to try and find the area of this triangle using the fact that you have two sides and included angle. Okay. Now, if you've got a question about that, now is a good time to raise your hand while students are working on this. But basically, you know that to use the area rule, you basically are going to fill in these three pieces. And so what is going to go in each of these brackets? And then once you've done that, I want you to pop your answer in the chat, please. So you can see how these rules can be used together. Like you had to find one piece and then another piece to go with it. So when using the area rule, we're going to use, so that's going to be 9, this is going to be 10, and this is going to be 49.46.
Mr. S?
Yeah.
There's a question from Amy Claire. If it doesn't matter what order the numbers are in.
Okay. It doesn't matter about the 9 and the 10. This stuff does not matter. There's always a half. It is important that the angle is the angle. So it is important that this over here was the angle we found here. Okay. But the front part, because multiplication order doesn't matter, it doesn't matter. Okay. So what are we getting for our answers there? Area 0.5 times 9 times 10 times the sine of 49.46. And we should be getting 34.20, if we round off, centimeters squared. Depending on, yeah, so if you round to two small places, I'm rounding like that. So that was the beginning of what I call a compound question, where we had to use two rules in one question. And so can we just do a quick thing in the class? If you understood this question, or you sort of understood, you understand the answer now that you see it, give me a thumbs up. Whereas if you feel completely lost, give a thumbs down. I just want to get a feel for the general sentiment of the class, realizing that we are going to go, the majority of students, I think, have been here for most of the lessons, but I want to include as many as I can. Okay. So for those students who possibly are a little bit lost, just hang in there because you're going to see similarities today as we keep going over the same stuff. Okay, take a screenshot now if you need to, and we're going to move on to the next question. Okay, the formula for the cos rule, it can be written in different ways. It depends on I'm going to suggest you look at an earlier lesson for that, because I'll write it out as we go today. Okay. So I'm going to write it out again in this question. So I'm going to tell you the journey for this question, and then you guys are going to help me work it out. So this is a compound question in that you have to use more than one rule. First of all, what am I asking you to find? I want to find the size of angle ABD. Now that's hanging out all the way over on this side. In order to get that angle, I suspect I'm going to have to find the bridge. I'm going to have to find this one over here. If I get that, it will help me. Now, if I wanted to find this thing called the bridge, let's start with that. What rule do you think I'm going to use to find the length BD? So what rule am I going to use to find BD? I want you to put that in the chat. So Neil, we're going to, and Nipo, we're going to slow it down here. So the end goal is to find the angle A, but in order to get the angle A or ABD, Oh, sorry, I've actually put the wrong, we actually want to get this one over here, but it doesn't really matter because we'll get there in the end. ABD is this one. First of all, we know we're going to have to find BD. And so let's start by saying, what do we use to get BD? In the chat, I am seeing sine rule. And I think you guys are on the right track. So if we want to find BD, how would we write out BD using the sine rule? I think it would be BD over the sine of 50 equals to something. And I want you to find what those two somethings are. And then when you're ready, I want you to give me the answer for BD. So let's start with that. Let's just take our time and do that. So what are those two going to be like then? Okay, so what did we got for? I'll wait a little bit longer. I'm going to turn my light on because it's going to get a little bit dark in here. What are we getting for our answer BD? So I've done a little bit of working for you. So you're going to go 8.4 divided by 68, 50. And we should be getting, let's have a look. I don't want to give the answer away yet. Yeah, so we should be getting 6.94. So what that means, guys, is that we know this yellow one is 6.94. Now, the good news is we've got all three sides in this other triangle. And remember, we're trying to find the red dot. What rule are we going to use? So I'm asking for an answer. I want to know, what rule are we going to use to find the angle ABD? Rafiwe, I think you're onto something. It's indeed the cos rule. So we know that the cos of ABD is equal to something. We're going to use the cos rule, but we're writing out the cos rule in terms of basically the way where we focus on the angles. And so I want you guys to try now and write out the cos rule where it's written in this form with a fraction, and we're trying to find the angle. And the hint I'm going to give you is to say the side opposite the angle that you want to know is the one that's most useful to kind of help you along the way. You're going to get a -5 squared here. Now, what you have to write above and below, what you have to write in these spaces, I want you to think about. Like what goes here and what goes there. And then once you've got all those, can you give me the size of the angle? Neville, won't you just hit neutral?
Mr. S, please unmute.
Cool. So for those, especially who are new today, I really encourage you to look at my earlier videos on this. I really went through this process in a lot of detail. And so if this is the first time you see me doing this, you may be thinking like, what is this man talking about? But for those, there's a real process we use in terms of finding an angle using the cos rule. We did a whole hour on that. Okay, so we want to find now what the angle is, but I'm going to do some calculator work. Okay, what are we getting for our angle in the chat there?
Majority says 43.53.
Okay, so let me just quickly check. 6.5 squared. That's 94. Yeah, so the first part here, you should be getting 0.725 and so on. And then if you hit shift cos answer, you should be getting 43.53 degrees. Okay, and so what that means, everyone, is that this one up here is going to be 43.53 degrees. That is going to be my answer. So you can see how powerful these things are when you start to put them together and use them together. But I think what makes it simpler is making sure you know how to write these rules out, you know the patterns in that scenario. Okay, fantastic. So guys, what we're going to do is we're going to take a quick little brain break. And so I want everybody to just quickly stand up for a second. We've been going for half an hour. Our brains have been working hard, and I'd love to see you stand up and just stretch with me for a second. And Label, if you could just focus and tell us about the students who are stretching the best. Okay. Okay.
Come on, guys, join us in the
Good.
stretch.
Oh, that feels good. All right. So we really like our students to stretch halfway through the lesson. We really think it helps a lot. And yeah.
Butle was just looking at us there, smiling like, oh my goodness, what are they doing?
All right, let's do it. Okay, so what I'm going to do is, because we're running a little bit short on time today, actually, let's squeeze in the brain break. A very quick little one. I want you guys to tell me, what is the weight of each animal based on this problem? What is the weight? We have we'll call it a teddy bear, a fox, and a rabbit. I want you to tell me what do each of them weigh? Elichle. Let's see. Elichle, what do you think it is?
I think the bear is 60 kg, then the rabbit is 10 kg, and the fox is 30.
It's going to be, you're almost there. So the bears were 60.
Yes.
And then the rabbits were 10. So what is the fox going to be?
20.
Absolutely. All right. Elichle, you are the superstar. Thank you very much. Jessica also got it. And so this is just an example of a simultaneous equation, guys. But you guys were onto that like chop chop. And so I'll make sure I keep these interesting going forward. Okay, let's get back to our questions about trig. Let us go to an old exam question here. And what I'm going to ask you to do is we're going to start by just doing one at a time. So you're given these two triangles, and I want to start by first working out, calculate the length of AC, correct to one decimal place. And what I want you to do in the chat for me is tell me what rule are you going to use. To start, what rule are you going to use to find AC? And then you go off and find it for me. Okay, I see some people are voting. A couple of people have voted already. They're saying what strategy they're going to use. So if I look at the triangle, I see one side, another side, and the angle in between them. And that reminds me of something called the cos rule. And so I'm going to start by writing out the cos rule, but I'm going to write it out where I write out the cos rule as if I'm finding sides. So my suggestion would be the cos rule. Could we use the sine rule here? I don't think so, because we don't have those matching pairs. Whenever we use the sine rule, we normally need to have a side and then a matching angle that's opposite that. And we don't have that here. Okay, so we're going to use the cos rule here. So find me AC. I'll give you a little hint. We start by writing out the cos rule as AC squared in this scenario. Because in this case, we're looking to find a side with the cos rule. So that's my hint. And let's see if you can find AC. Over to you guys. So think about one of the
Looks like Boyani has already found it.
well, but is he right? We don't know. We don't know. You see, the mystery is still out there. So in terms of writing this out, this is the way I would have written it out here. But now there's still a little bit of work to be done before we get to the final answer. Because it says AC squared on the side, and this, obviously we need to do something. And so what are we going to get for that amount? Okay, so I use my answer key and I get somewhere around the 708.169 da da da. And then for AC, I'm just going to get square root of that. And we should be getting 26.61. We'll round to two decimal places here, meters. Okay, so we've got this over here, 26.61 meters. We now need to find the size of BAC. So BAC is going to be this angle over here. Now here we have a choice. We can either use the cos rule, because we've got all three sides, or we can use the sine rule. Both of them should give us the correct answer. However, we just need to remember that when we use the sine rule, there is the chance of having two answers. And so it's up to you guys to decide. Which do you think would be easier here, the cos rule or the sine rule to find BAC? Tell me in the chat which one you would prefer. Okay. So I think the sine rule is marginally quicker, but it is the chance of making a silly mistake is also there because of the, yeah. Okay, so both ways. Let me use the cos rule because most people are saying cos rules, and that's fine. But those who want to do it with the sine rule, do it with the sine rule, and then we can compare our answers, and you'll see that you'll get the same answer. So we'll start by writing the cos of BAC is equal to something. And I want to see if you can write that out, and then we'll get our answer straight after that. So what's that going to be? Minus 12. And then this is going to be. Okay. Let's wait a bit of time to see what our answers are. Okay, so oh, wait. 9057. Now, I'm using the answer key in my calculator, but I'm getting about 0.9057 as the number. But if I then go shift cos whatever the answer was, I should be getting an angle of 25 basically 25.1 degrees. And so that would be this red one over here. 25.1 degrees. All right, so we've got that one over there. What we're going to do now is we are going to try, so we've got BAC and it's 25.10 degrees. That's this one over here. The next question asks us to find D, which is over here. And then it says, after you find D, you need to find the area of this entire land piece, ABCD. And so what I'm going to ask you to do is this is going to be our last question of the day, but I want you to all try and do these last two questions. They're worth 6 marks. And then students who have other questions, while students are working on that, you can raise your hand now, and I'll see if I can take some questions from you. Otherwise, just keep on working and see if you can do questions C and D. For those who used the sine rule, did you guys get the same answer as me as 25.10? Does anybody want to tell us? Maybe jump on the line and or confirm in the chat that you did indeed get the same answer as us. I just want to assure everyone, okay, Rafiwa is saying yes, they got the same answer. And so if you had used the sine rule for this question here, it wouldn't have been a problem. You would have got the same answer. Okay. That's the good thing about maths. We are telling the truth. So it does work out. Like when you're a substitute. So immediately, I think you're talking about the answer. So basically what I do is I type this thing into my calculator and I hit the equal sign. And when I hit the equal sign, it gets stored in the key called answer. And so then at this point over here, I just go shift cos and I put the answer key in, which brings the value of that working out back for me. I think that's what you mean. Okay, so let's see what we get for the cos of D. I'm running out of space here a little bit. Now I know I'm gonna get okay. So if I wrote out my attempt to get D, I get this, but there's still work to be done before I get the value of D. And so let's see how we can get that. I see a couple of answers are coming through. And then I get so we should be getting 71 point it says to one decimal place, so 419, so it'll be to 71.4, and that would be D. All right, last part of the question, guys. I want to now find the area of this whole thing. The good news is you basically just need to find the area of this one triangle down here and then the upper triangle up there. And so we know, what do we need to know? We basically, all we need is that this angle is 71.4. And then we are going to use the area rule to find the size of each of these triangles and then add them together. So over to you guys. Find me the area of the entire piece of land A, B, C, D. And then I think we've had a good solid lesson where we've definitely used combinations of rules throughout the lesson. And we've even looked at some past exam questions like this one. So we need the area of triangle ABC, and we need the area of triangle, let's call it ACD. Times sine of 110. And then this one is going to be a half. Okay. Let's see what those answers are. Let's get them, keep them coming in the chat. Be about 92 points. Okay, and you should be getting 205, and I'm going to round it off to one decimal place. So 205.6, and that is going to be meters squared.